Good morning, boys and girls, and welcome back. Mr. Murtara here again today. And today we're going to talk about applying the properties of logarithms. Okay. The main thing we're going to do with our properties today is called expanding. That's when you're going to try to make things longer. But there's also condensing or compressing, and we'll talk about that tomorrow. All right. But before we jump into the properties of logs and expanding, we're going to do a quick little review / talk about evaluating logs using exponential form. If I want to know what log base 5 of 1 is, we can use exponential form to help us look at that. Again, what I need for exponential form is I need an equal sign. So I can say equals, and this is going to equal something, equal some blank, right? Okay, I know the base has to stay the same, so our base is going to be 5, and it's not to the 1 power, so whatever's on the other side of the equal sign. So 5 to the blank equals 1. And now we're just going to ask ourselves, like, hey, if I'm thinking about it, 5 to what power equals 1? 5 to what power equals 1? And hopefully after you think about it for a while, you're like, well, I know, anything to the 0 power, hey, that's going to equal 1. Therefore, my blank has to be 0. Or log base 5 of 1 is going to equal 0. That would be our answer. Okay. The moral of the story is, I guess it doesn't matter in this case what our base was, right? We said anything to the 0 power is 1. So, anytime you take the log of 1, okay, doesn't matter your base, log base 5 of 1, log base 3 of 1, it is always going to give you 0. All right, let's apply the same stuff to number 2, ln of 0. What is that? Well, again, I need a base, and so ln is base e. And again, we need an equals blank. So there's going to be e to the blank equals 0. E to the blank equals 0. E to what power equals 0? Well, if we start thinking about this, e is our exponential growth function, and e's never got to 0. They got really close to 0, right? There was an asymptote there that had approached and approached, but it never actually equaled 0, okay? So this we say is undefined. This cannot happen. There is no value. I cannot take ln of 0. It does not work. Even if we bring up our handy-dandy calculator and I try to take the ln of 0, it's going to say, hey, wait, there's an issue. We can't do it. There's an error in our domain, okay? So you just need to know that the ln of 0, or the log, any log of 0, again, is going to be undefined. We can't do it. Doesn't matter what your base is. Okay, so now let's move on to number 3. If we do our equal sign equals blank, I get 6 to the blank equals negative 3. What would I raise 6 to give me negative 3? And again, you're going to come across this. If I raise 6 to any power, it's always going to be positive, right? It will never equal a negative number. So again, in this case, you cannot do it, and this is undefined. Again, that's an exponential growth function. It never goes negative, right? It always stays positive. It never goes negative. So that is also undefined. You need to know that you cannot take the log of a negative number. Okay, on this last one here, we have log base 3 of 27 equals blank. So 3 to the blank equals 27. Oh, good. This one we can do, right? 3 to the third equals 27. Now, what we're going to expect you to do when you see things like log base 3 of 27 is we're going to also, hopefully going back to our day 1 stuff, we're going to expect you to recognize that 27 is a perfect cube. And so if I rewrite this as log base 3 of 3 cubed, going back to our first day stuff, another way you could do this is when the bases are the same, we said, they will kill each other out. And so I'd be left with just 3. Either way, log base 3 of 27 is 3. Kind of two different ways to come up with that answer, but we need to be able to do that. Okay, so quick summation of what we just talked about. The log of any base of 1 is always going to be 0. You cannot take the log of 0, though. That is undefined. Or the log of a negative is undefined. Okay? But if you notice that you have a perfect cube or a perfect whatever the base is, in this case a cube, you better rewrite it so that you can kill those things off. Okay? Or rewrite it so you can do it. Sorry, my computer just went a little haywire there. Hopefully yours is, it didn't happen too bad on the video there, but we're back and running up now. Let's talk properties of logs, all right? There's really only 3 properties of logs that you need to know, all right? The first property is the product property, and that says if you are multiplying 2 things in the argument, okay, log base b of m times n, if you're multiplying 2 things, then you could expand that, you could make it longer to log base b of m plus log base b of n. Okay? Expanding is making something longer or bigger, kind of like to the side over here. Okay? This property works both ways. You could also take something long and condense it and make it shorter. One little thing. Today we're going to work on the expanding piece. We're going to make things longer. We're going to start with a nice little expression, and we're going to write it long ways or write it out. Okay? Our next rule is the quotient property that says if you have two things that are dividing, you could subtract those. Okay? With these rules, if it helps you, these are again kind of, logs and exponents are related to each other, and we know that when we multiply bases, you add exponents, and when you divide bases, you subtract exponents. That's, again, kind of where these rules are coming from. So it helps you to remember that. You can kind of use that, all right? So the product property, if things are multiplying, you add them. Quotient property, if things are dividing, you subtract them. The power property says if you have an exponent in front, what you could do is you could take that exponent and you can move it to the front of your log. So the exponent can go from the exponent on the argument, and it can go in front of your log, just like that. So n log base b of n. All right? So now we're going to kind of use these, and today is just all about playing around with these three rules and getting comfortable with them. Some of the stuff we're going to do is kind of silly, like this next part is there's not a lot of reason why we're doing it other than to play around with these three properties. Okay, so in this next part here, we're given log base 5 of 4 is 0.861. And we're given log base 5 of 9 is 1.365. And so we want to rewrite log base 5 of 4, 9, so that we can evaluate it. Okay? So using our properties from above here, because these are dividing, we're going to use the quotient property. But because these things are dividing, I could rewrite this as log base 5 of 4 minus log base 5 of 9. Okay? When you were dividing in the argument, you could rewrite it as a subtraction problem. And now, again, they gave us a what log base 5 of 4 and log base 5 of 9 are, so we can replace and evaluate. This would be 0.861 minus 1.365, which is negative 0.504. Really, again, the answer is not super important, okay, on this stuff. Getting that answer is just an easy way to check that you did things correctly. That's the good thing about the answer. The important part of this was this step right here, going from the problem and rewriting user properties. That's what we really want to practice today, okay? So make sure you are showing your work and showing that step. Very important. All right, some of these now, like on number 6, get a little bit trickier, okay? I got log base 5 of 36. Now what I need to do is I want to rewrite this thing so I can use, again, the 4 and the 9, right? So that I can evaluate this problem. But you might have to think about things a little bit. I like them because they kind of become a little puzzle. But I guess I could rewrite log base 5 of 36 as log base 5 of 4 times 9, since 4 times 9 is 36, right? And now that I know that these things are multiplying, now I can use my logarithmic properties to expand this out to log base 5 of 4 plus log base 5 of 9, right? Using that first product property we had above. That, again, is the important part, using these properties, right? Now I can substitute in the numbers, though, and get an answer to check myself. And we get 0.861 plus 1.365, or 2.226. All right? Again, answer just a way to check ourselves. The important part is the work. That part right here is the important part. Okay, so same thing on number 7. I want to rewrite this. I want to rewrite 81 so I can use these properties. And now, so it's a true statement that 81 is 9 times 9, so I guess we could do that, right? But again, our point tonight is to practice the properties. So make sure you don't just practice the same property over and over. Try to practice all 3 of these properties on problems like this. So I could say 81 is 9 times 9, but we haven't used the product property yet. So maybe let's also, or the power property yet. So let's try to rewrite this instead as log base 5 of 9 squared. All right. Now using the power property, if I have an exponent, we said you could take that exponent and move it to the front. And so I could rewrite this as 2 log base 5 of 9, or this would be 2 times 1.365. And this would give me 2.730. All right. If you did this problem a different way, you should get the same answer, or if not, a very close answer. These ones up here are approximations, right? They're not exactly equal. So depending on how you do the problem, it might be off by just a little bit, maybe just by this last number here, or they should be exactly the same. Okay? But just know that you can be off just a little bit because we're dealing with approximations. But make sure you practice all three properties tonight when you do the problems like this. All right, on this last little bit here, we're going to use our properties of logs to expand the following logarithmic expressions. All right, I want to make them big, long statements. All right, so I'm going to start by, on number 8 here, I want to start by isolating the base with the x. I can't move the 7 to the front because that is not all the base. Okay, the 7 is only on the x. So I'm going to start by isolating that by expanding using my product property. Because the 5 and x to the 7th are multiplying by each other, I can separate those with a plus sign. Log of 5 plus log of x to the 7th. And now to expand some more, I can take the exponent on the x and I can move it to the front. And now I've taken our nice little condensed statement and I've written out long ways. This would be our expanded form. These things are the same thing, they just look different. All right, let's do the same thing with number 9. Let's expand our log base 3 of 7x squared over y. In this case, what's probably scaring us the most is the fraction, so let's undo that first. When things are dividing, you can, again, expand them with a subtraction sign, right, using the quotient property. And now I can undo this part similar like to the way we did in number 8. Because 7 is multiplying x squared, I could undo that with a plus sign. Log base 3 of 7 plus log base 3 of x squared minus log base 3 of y. And then again, using our power property at the very last, I can move that square to the front. And this would be our expanded form, written out as far as we can. And again, this is just the whole point of today. I mean, again, it might seem silly, but it's just to practice these properties, expanding, condensing stuff. Because we're going to use these properties when we start to solve exponential and logarithmic equations. All right, let's get crazier still and move on to number 10 here. And again, we want to start by undoing our fraction. When you divide, you can expand with a minus sign. And when you do this, just do one property at a time, okay? One property at a time. Now, in this case, in the front, because the squared is on that whole thing, now again, I can bring that to the very front, okay? Because it's on the whole thing, and, you know, before it was just on the x. And again, I'm just playing with one rule at a time, all right? Next, now again, I've got things multiplying, so I'm going to expand those with plus signs. Few things when you do this. When you expand something and you've got a number in front, like in this case I had the 2 in front, I need to keep that stuff in parentheses because that 2 went to all that stuff. Or same thing here, this minus sign, this negative went to all that stuff. So you need to keep it in parentheses or you're going to have to distribute it to everything. Okay, you can do it either way, but I tend to keep my stuff in parentheses. So be careful if you've got a minus sign, -1 in front, or like a 2 in front. When you expand, continue to expand, keep it in parentheses. All right, now, next little bit here. Going back to what we started with today, I'm recognizing that 16 is 4 squared. And this is a log base 4. So because those bases are the same, we could reduce that. That will simmer down and become just a 2. Okay? So when you see you have the same bases in your exponent and your log, you need to simplify. The other thing I'm saying is that with the square root of y, I could rewrite that as y to the 1/2. And the reason I want to write it as an exponent is then again I can expand some more and bring that 1/2 to the front. Okay, so rewriting that now we have 2 times 2 plus log base 4 of x minus log base 4 of 3 plus 1/2 log base 4 of y. Or if you distribute the stuff in front, really this expanded form would be 4 plus 2 log base 4 of x minus log base 4 of 3 minus 1/2 log base 4 of y. I think is the answer that you would see. This one by far is the trickiest and as hard as they will get. So if you got that one down, you're in good shape. If not, we will continue to work at it. All right, let's step back and do another easy one to wrap things up today. All right, remember ln's are logs, so we can apply all these log properties. And again, we're going to start with the quotient property. And we get ln of 7y cubed minus ln of 4x squared. Now, again, these are multiplying together, so I'm going to undo them with the product property. In this case, again, the exponents are only on the variable, not on everything. So I want to expand first with my product property. Again, you only want to do one property at a time, but you can do it to more than one thing. Like I expanded both terms with the product property. Also, because we have the minus, make sure you keep the back in parentheses. And then now lastly, we can use our power property and bring the powers to the front. And when you do that again, maybe you distribute the negative on that set of parentheses, or maybe you don't. You don't have to. You could leave it inside parentheses, but your final answer should look something like this. All right, boys and girls. Again, if you got questions, come find us. See you later. Have a nice day.